Okay, all done. So to summarize, what would we do? We want to create a vector of the content of a document. So here we're using Shakespeare's plays, but you can apply it to anything you wrote as well. Yeah, we are looking at all the words. We started out with a binary count. We said this is not good enough if you want to be able to rank it. So we started looking at the raw count. And we said, okay, that's also not good enough because we give a high number to words that are not so important, like the, a, n, and it also depends on the length of the document. So we wanted to have this weight that combines the frequency and the informativeness of a word. And this is known as the tf-idf weights. So this is how our document vectors are going to look like. So a long vector of tf-idf weights. And this is the vector space model applied as documents. So now we represent a document as a vector, and the vector is a representation of the actual content. So what is written in a news article, a blog post, a movie description, and so on. When you do this in a search engine context, then this is a very high number of dimensions. So you have tens of millions of dimensions. And in those vectors, most entries are going to be 0. So in terms of calculation and vector representation, there is something called a sparse representation, so that you save memory. You only represent the ones where the value is actually 1. To conclude, I'll just show you how this is used for a search engine. And this is the same idea what we've done before with the cosine similarity. Yeah, we want to know how similar is a document to a search query. You type in the query like best movies with zombies, and then you want to match this query to all the movie description, to all the content. I do this again with the cosine similarity. You have the query vector. So again, in a search engine, this is what you would type into the search box, the search terms. You transform this into a vector, and then you simply look at the similarity of this vector to the vectors representing the documents using the same formula as before. So we are just doing the dot product. And this is the general formula in case they are not normalized. Then you have to divide it by the length. But if they are normalized, then you just multiply these vectors like you did before. So then you'll find out for a given search query, which is the closest, the second closest, the third closest, and this is simply your list of search results. The top K documents that match the input query. And in terms of recommendation, it's the same thing. You start from, for example, one movie description, or you start from one blog post, look at the content, and then you do the same similarity matrix as we did before, except now we are doing it with the tf-idf content vector. And then we give a recommendation based on the content. So today you learned one thing that you'll see many times later on in the course, the idea of a vector space model. So here we can represent something in an n-dimensional space, and each entity is represented with a vector in this n-dimensional space. In our case, we used it for describing items that we want to recommend, books, movies, and so on. And once we have the vectors, we can find out how similar they are by computing the cosine of the angle between the two vectors as a measure of similarity. What you've done by hand on the worksheet will do in the lab in Python programming with a number of libraries. And you should also be aware, if you want to apply this on a large scale, there is software, libraries and servers where this is obviously already implemented. So one very well-known library is Lucene, an Apache project, which does all of these calculations for tf-idf vectors, similarity, and so on. And then there are servers that use Lucene for indexing documents and having a search interface and web service and so on. And one of them that's very well known is Solr. Okay, you made it to the end of the lecture. Some notes on what you have to read. For the recommendations for the first part, collaborative filtering, look at this book here, Collective Intelligence in Action, and this you can read again online on Safari Books online through the library. For evaluation, and also if you want to know more, if you want to read up again on the vector space model, tf-idf, and so on, have a look at this book here, Introduction to Information Retrieval. And this one you can read for free online. So this is a very good book, and it's written by 3 very well-known people. Manning and Schütze are 2 professors in computer science, and Ragavan is, not sure if he still is, but he was the head of research at Google Search. So this is really a good book, and you get it for free. So much for this lecture. Good luck with the exercises. We'll see you again in the next week. Goodbye.